Thank you for joining another math lesson hosted by Book&Table. I am your math tutor Maurice Wright, and in this video we're going to review how to solve radical equations. We'll first take a look at how to remove one or several radical signs from an equation so that you can solve for the variable. And then we'll also discuss the several methods that you can use to solve for the variable once those radical signs have been removed. Should you have any follow-up questions, feel free to leave them in the comment section. Or of course, you can contact a tutor in your area by visiting bookandtable.com or by downloading our app on the App Store. An equation that includes a radical sign is considered a radical equation. The radical sign or signs must be removed from the equation in order to solve for the variable, which is usually x. So this would be an example of a radical equation. The square root of 4x squared minus 13 is equal to 2. So we have an equation. We have two expressions with an equal sign between them. And we have a radical sign. This would also be an example of a radical equation. The square root of 2x plus 7 plus the square root of x minus 1 is equal to 4. So I'll walk through how to go about solving each of these types of radical equations. But before we jump into that, we first need to discuss the difference between radical form and exponential form. The radical form of a term includes a radical sign, and the exponential form contains a fractional exponent. So these two terms have the same value, they're just written differently. Again, in radical form, we have our radical sign. So this value, we have our base, which in this case is our radicand, a. It's being raised to a power of m, and this power m is being divided by the index n. In exponential form, this would be represented by a fraction, so it's a to m divided by n. So using this, knowing that this is the exponential form of a term, we can see how we go about removing a radical sign. To remove a radical sign, you want to raise both sides of an equation to the power equal to the index. So if we have our term a to the m over n, we want to raise this entire term to a power of n. Why is that? Well, again, in exponential form, it would be a to the m over n. And now when we raise this to another power, this term multiplies against this exponent. So this n negates this n, leaving you with just m. So this cancels out the radical term, leaving you with what's just underneath the radical sign. So if we look at it with actual values, if we had 7 to a power of 3 halves, it would be the square root of 7 to a power of 3, which in exponential form would be 7 to 3 halves. And then we raise that to a power of 2, since our index is 2. Those 2's cancel each other out, leaving you with just 7 to the third, which is the term underneath the radical sign. If we change our exponent and our index, we still go about removing the radical sign the same way. This term would be 7 to a power of 6 over 3. So you would raise both sides of the equation to a power of 3. This 3 cancels out our index 3, leaving you with just 7 to a power of 6, the term underneath. And no matter what values you plug in there, the index could be 4. 7 to a power of 6/4, raise both sides to a power of 4. The 4's negate, leaving you with just 7 to a power of 6. So throughout this video, all of the examples would be square roots. The index will be 2. But if you are given questions where the index is something else, the only thing that changes is the power that you will be raising both sides of your equation to negate that radical sign. Okay, so keep that in mind. So now let's have a look at a radical equation and how we would go about removing the radical sign from this equation. All right, we'll save how to solve for the variable for later on in this video when we get to sections 4, 5, and 6. For now, we're just going to focus on removing the radical sign. So let's say you were given this radical equation, the square root of x squared minus 7 plus 13 is equal to 8. The first thing you want to do is isolate the first radical term. So you want to take all the other terms on the same side of the equation as the first radical term and move them to the other side. So in this case, the only other thing on the same side of the equation as our radical term is this constant, positive 13. So step 1, subtract 13 from both sides. That negates this term, 13, leaving you with just the radical term on the left side, the square root of x squared minus 7. And on the right side, you now have 8 minus 13, which would give you negative 5. Now, once you have the radical term isolated, we want to take advantage of the fact that the index is 2. So we're going to raise both sides of the equation to a power of 2 to get rid of this radical sign. Now, in exponential form, again, remember this radical is the term underneath to a power of 1/2. It's this term to a power of 1. It's not shown, so it's a power of 1. It's just itself. So that's this. And the index is 2, so that's the denominator 2. Okay, so a radical term with an index of 2, you raise it to a power of 2 because 2 times 1/2 would be 1, leaving you with just the term underneath, which would be x squared minus 7. Isolate the radical term, so we subtract our constant 13 from both sides. Once you have your radical term, you then want to raise both sides of the equation to a power of 2, since the index is equal to 2. That cancels out the radical sign, leaving you with just x squared minus 7 is equal to 25. And then you will be able to proceed from there to solve for the variable x. Again, we'll solve for the variable later on in the video. Just want to review how to remove the radical sign. Let's have you do a few practice questions. Remove the radical sign from each equation. Question number 1, the square root of x minus 8 is equal to 3. Question number 2, the square root of x squared plus 5 minus 3 is equal to 2. And question number 3, the square root of x squared minus 1 plus 6 is equal to 4. Pause the video, solve these questions, and then press play when you are ready to begin. Step 1, add 8 to both sides. This is to help us isolate the first radical. So that leaves us with the square root of x on the left side and 3 plus 8, which gives us 11 on the right side. Step 2, raise both sides to a power of 2. Since our index is 2, when we raise both sides to a power of 2, that negates that radical sign, leaving you with just x on the left side. 11 squared would be equal to 121. So once you remove the radical sign from this equation, you're left with x is equal to 121. All right, we'll discuss how to check your answer later on in the video, but for now, we're just discussing how to remove the radical sign. Let's take a look at question number 2. We had the square root of x squared plus 5 minus 3 is equal to 2. We want to isolate the radical term. So step 1, to negate this constant, we want to add 3 to both sides, leaving us with the square root of x squared plus 5 on the left side of our equation, and 2 plus 3, which leaves us with 5 on the right side of our equation. Step 2, we want to negate this radical sign by raising both sides to a power of 2. That 2 negates this index of 2. When we do so, the radical sign is removed, leaving us with just x squared plus 5 on the left side. And on the right side, we have 5 squared, which should be equal to 25. So once we remove the radical sign from question number 2, you are left with x squared plus 5 is equal to 25. Question number 3, we had the square root of x squared minus 1 plus 6 is equal to 4. To isolate this radical term, step 1, subtract 6 from both sides, leaving us with the square root of x squared minus 1 on the left side of our equation, and 4 minus 6, which is equal to negative 2 on the right side of our equation. Step 2, raise both sides to a power of 2. When we do so, the radical sign is removed, so you're left with x squared minus 1 on the left side, and negative 2 squared is positive 4 on the right side. So that is how you would remove a single radical from a radical equation. Before we discuss how to then solve for the variable x, let's now discuss how to remove multiple radicals from a radical equation. This isn't drastically different, it's just a bit longer and a bit more tedious. You're essentially going to do the same thing that we just did for single radicals, just multiple times. Okay, so solving a radical equation with multiple radical signs is similar to solving an equation with a single radical sign. Isolate and remove the radicals one by one. So you're first going to isolate the first radical sign, remove the radical sign, and then you'll isolate this term and then remove it. So what does that look like? We have the square root of 2x plus 7 plus the square root of x minus 1 is equal to 4. So in order to isolate the first radical term, you want to remove all the other terms on that side of the equation to the other side of the equation. So in this case, we have a second radical on the same side as our first radical. So step 1, you're going to subtract the second radical from both sides. So instead of adding the square root of x minus 1, you're going to subtract the square root of x minus 1, leaving us with just the first radical on the left side. And now on the right side, we have 4 minus the square root of x minus 1. Step 2, we're going to raise both sides to a power of 2. That helps us get rid of this radical sign. So we're just left with 2x plus 7 on the left side. I'm going to skip the individual steps on the right side, but this 4 minus the square root of x minus 1 squared would become 15 plus x minus 8 radical x minus 1. And now we want to isolate this second radical and do the same thing we did here. So again, we're going to move the terms on the same side as our radical sign to the other side. That way we can isolate this radical. So step 3, subtract x from both sides. And step 4, subtract 15 from both sides. When you do that, 2x minus x gives you x. 7 minus 15 gives you negative 8. So you're left with x minus 8 on the left side. And now on the right side, we have just the radical sign. The coefficient is fine. Now, what we can do is we raise both sides to a power of 2 to get rid of this radical sign. So you'll have to use the FOIL method to expand the left side. And then on the right side, you square the coefficient. Negative 8 squared gives you 64. Anytime you square a radical times itself, you're left with just the term underneath. So we get x minus 1. And now we have our polynomial without our radical signs. To solve a radical equation with two radicals, isolate the first radical sign raise both sides to a power equal to the index, and then isolate the second radical sign, raise both sides to a power equal to the index, and then your radical signs will be completely removed from the equation. Let's have you do a few practice questions. Remove the radical signs from each equation. Question number 1, the square root of x plus 1 minus the square root of x is equal to 2. Question number 2, the square root of x plus 3 plus the square root of 5x is equal to 7. And question number 3, the square root of 4x minus 4 minus the square root of 2x plus 1 is equal to 1. Pause the video, answer these questions, and then press play when you are ready to begin. So question 1, we had the square root of x plus 1 minus the square root of x is equal to 2. Step 1, add the second radical to both sides. This helps us isolate the first radical, the square root of x plus 1, on the left side of our equation. Since we're subtracting this radical, we want to add the radical to both sides so they negate, leaving you with 2 plus the square root of x on the right side. Now to remove this radical sign, since the index is 2, you want to raise both sides of this equation to a power of 2. This leaves you with the term underneath, x plus 1 on the left side. And on the right side, we have 2 plus the square root of x squared. So now you want to use the FOIL method to expand this expression. So FOIL stands for first, outside, inside, and last. So first means you're multiplying the first term in each set of parentheses. Right? Since we're squaring this, you have to multiply it by itself. So you take this term and you multiply it by both terms of this binomial. So it's the first term in each set of parentheses, and then it'll be the outside. So that term times this term. The I is inside, so you go to your second term now. You multiply it by this term. So it's the inside terms. And then last means you take this term again and multiply by this term. So once we start to expand the expression, we start with 2 times 2, which would leave us with 4. Then we do 2 times radical x, which gives you 2 radical x. Radical x times 2 gives you 2 radical x. And radical x times radical x leaves you with x. Now 2 radical x and 2 radical x can be combined since they are like terms. They have the same term underneath the radical sign. So you combine them by adding their coefficients. 2 plus 2 gives you 4 radical x. So once you use the FOIL method to expand, we wind up with 4 plus 4 radical x plus x. So this is what our equation looks like once our first radical sign is removed. Now you want to move this term and this term to this side to isolate this radical sign, and then we'll do the same thing again. So step 4, subtract x from both sides. And step 5, subtract 4 from both sides. This leaves you with 4 radical x on the right side. X minus x is 0x. 1 minus 4 is negative 3. And now we want to raise both sides to a power of 2 to get rid of this radical sign. So step 6, raise both sides to a power of 2. Negative 3 squared is equal to 9. 4 radical x squared is 4 radical x times 4 radical x, which would be 4 squared, which is 16. The square root of x times the square root of x is x. So once we remove our radical signs from question number 1, we are left with 9 is equal to 16x. Again, we weren't solving for x, that's why I stopped here. I just asked you to remove the radical signs. But as you can see, x would be equal to 9 over 16 here. Let's take a look at question number 2. The square root of x plus 3 plus the square root of 5x is equal to 2. We want to isolate the first radical. So step 1, subtract the second radical from both sides. That leaves you with the square root of x plus 3 on the left side and 2 minus the square root of 5x on the right side. To remove this radical sign, we raise both sides to a power of 2. That cancels, leaving us with the radicand x plus 3. On the right side, we wind up with 2 minus the square root of 5x squared. So we're going to use the FOIL method to expand this expression. 2 times 2 is 4. 2 times negative radical 5x is negative 2 radical 5x. Negative radical 5x times 2 is negative 2 radical 5x. And negative radical 5x times negative radical 5x is positive 5x. Negative times negative is positive. Negative 2 minus 2 would give us negative 4 radical 5x. So once we remove our first radical sign, we have x plus 3 is equal to 4 minus 4 radical 5x plus 5x. You now want to isolate the second radical. So we are going to move this 4 over here and this 5x over here. So step 4, subtract 5x from both sides. X minus 5x is negative 4x. Step 5, subtract 4 from both sides. 3 minus 4 is equal to negative 1. So that leaves us with negative 4x minus 1 is equal to negative 4 radical 5x. Now the next thing we want to do, since this radical is isolated, we want to raise both sides of the equation to a power of 2. So we wind up with negative 4x minus 1 squared on the left side. And once we square the right side, the radical is removed. And we're left with negative 4 squared, which is 16. And what's left underneath the radical sign, which is 5x. So the answer to question number 2 is negative 4x minus 1 squared is equal to 16 times 5x. But let's go over the last practice question, number 3. The square root of 4x minus 4 minus the square root of 2x plus 1 is equal to 1. We want to isolate the first radical. So step 1, add the second radical to both sides. That leaves you with the square root of 4x minus 4 on the left side of the equation. And on the right side, we have 1 plus the square root of 2x plus 1. To get rid of the radical with an index of 2, step 2, raise both sides to a power of 2. On the left side, you're left with just what's underneath the radical, which is 4x minus 4. And on the right side, we have 1 plus the square root of 2x plus 1 squared. So step 3, we're going to use the FOIL method to expand this expression here. So the first term, we multiply those in each binomial. 1 times 1 is 1. The outside terms, 1 times the square root of 2x plus 1 is the square root of 2x plus 1. Our inside terms, radical 2x plus 1 times 1 is radical 2x plus 1. We add that to our other square root of 2x plus 1, so we wind up with 2 of them. And then we multiply the last term of each binomial. So the square root of 2x plus 1 times the square root of 2x plus 1 is 2x plus 1. So we are left with 4x minus 4 is equal to 2. 1 plus 1 will give us 2. 2 plus 2 radical 2x plus 1 plus 2x. So now we want to isolate the second radical by moving the variable and constant to the other side of the equation so that we can have just the radical. So step 4, subtract 2x from both sides. 4x minus 2x leaves you with 2x. We want to subtract 2 from both sides. Remember, we had 1 plus 1, so I combined them here. So we subtract 2 from both sides. Negative 4 minus 2 gives us negative 6. So we have 2x minus 6 on the left side. And on the right side, we've successfully isolated our second radical sign. So now we raise both sides to a power of 2 to get rid of this radical. So the final answer to question number 3 is 2x minus 6 squared is equal to 4 times 2x plus 1. So that is how you would go about removing one or multiple radical signs from a radical equation. For the remainder of this chapter, we are going to discuss 3 different ways that you can go about solving for the variable once you remove the radical sign or radical signs. So we'll first discuss how to solve for the variable algebraically. We'll then discuss how to factor the polynomial that you are left with. And then we'll wrap things up by discussing how to solve for the variable by utilizing the quadratic formula. So let's first discuss how to solve for the variable algebraically. So to find the solution algebraically, once the radical signs are removed, if the variable only appears once in the equation, then solve the equation by isolating the variable on one side of the equation. So let's say you started off with the square root of x squared minus 7 plus 13 is equal to 8. Once the radical sign is removed, you are left with x squared minus 7 is equal to 25. So the variable x only appears once. So we first isolate it on the left side of the equation, so you would add 7 to both sides. And now, since x is on the left side and we have a constant on the right side, we can remove the exponent 2 by taking the square root of both sides. So you would be left with x is equal to 4 radical 2. You remove the radical sign, and if the variable appears once, you isolate that variable on one side of the equation and solve for it with an exponent or power of 1. Let's take a look at a question that had 2 radical signs. So we had the square root of 2x plus 9 minus the square root of 101x is equal to 0. So we want to isolate the first radical. So we add the second radical to both sides. That leaves you with the square root of 2x plus 9 is equal to the square root of 101x. To get rid of this radical sign, you want to raise both sides to a power of 2. This actually removes both radical signs at the same time. This only happened because our constant here was 0. If we had another number such as 1 plus this, then we'd have to use the FOIL method to expand this. But I just want to show you an example so that you could see that you can be given 2 radical signs and you may be able to get rid of both of them at the same time. So that would leave you with 2x plus 9 is equal to 101x. Now the variable appears twice here, but since you can subtract 2x from both sides, that would leave you with 9 on the left side, and 101x minus 2x would leave you with 99x on the right side. So once your radical signs are removed, if the variables are to the same order, this has a power of 1, this has a power of 1, those like terms can be combined, and then you'll see that the variable appears once. Okay, once they're combined. And now we can go ahead isolating it. So since this has a coefficient of 99, we want to divide both sides by 99 to get rid of it, leaving you with x is equal to 9 over 99, which is equal to x is equal to 1 over 11, which is equal to 0.09. So the answer is x is equal to 0.09. And then step 5, to check this answer, plug it into the original equation. So the original equation was the square root of 2x plus 9 minus the square root of 101x is equal to 0. We plug in 0.09 in both places where we see x. 2 times 0.09 is 0.18 plus 9. 101 times 0.09 gives you 9.18. So that leaves you with the square root of 9.18 minus the square root of 9.18. Anything minus itself is 0, confirming that the left side of the equation is equal to the right side. So the answer x is equal to 0.09 is correct. Let's have you do a few practice questions now. Solve for x and check the answer. Question number 1. The square root of x plus 5 minus 8 is equal to 22. Question number 2. The square root of 12 minus x plus 7 is equal to 14. And question number 3. The square root of x plus 3 minus the square root of x minus 7 is equal to 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We were given radical x plus 5 minus 8 is equal to 22. You want to isolate the radical, so you remove the constant on the same side as the radical. So step 1, add 8 to both sides. Negative 8 and positive 8 cancel, leaving you with just radical x plus 5 on the left side. And on the right side, you have 22 plus 8, which gives you 30. And now to remove this radical sign, since the index is 2, you want to raise both sides to a power of 2. That 2 and this 2 cancel each other out, leaving you with just x plus 5 on the left side. Since you squared the left side, you have to square the right side. 30 squared is equal to 900. Now that our radical sign is removed, we can solve for x algebraically by subtracting 5 from both sides. So that's step 3, leaving you with x on the left side and 900 minus 5, which is 895 on the right side. So the answer to question number 1 is x is equal to 895. And then step 4, check the answer by plugging it into the original equation. The square root of x plus 5 minus 8 is equal to 22. We plug in 895 for x. 895 plus 5 is 900. The square root of 900 is 30. 30 minus 8 is equal to 22. So since the left side equals the right side, that confirms that x is equal to 895. Let's take a look at question number 2. The square root of 12 minus x plus 7 is equal to 14. Step 1, subtract 7 from both sides, leaving you with just the radical on the left side, and 14 minus 7, which is 7 on the right side. Since the index here is 2, to remove this radical sign, you want to raise both sides of the equation to a power of 2. That leaves you with 12 minus x on the left side, and 7 squared, which is 49 on the right side. So now we can solve for x. So first, let's subtract 12 from both sides. When we do that, we have negative x is equal to 49 minus 12, which is 37. To remove this negative, we can multiply both sides by negative 1. Negative 1 times negative x is x. Since you multiply the left side by negative 1, we have to multiply the right side by negative 1 also to keep the equation balanced. So we wind up with x is equal to negative 37. And then step 5, check the answer by plugging it into the original equation. radical 12 minus x plus 7 is equal to 14. When we plug in negative 37 for x, we wind up with 12 minus negative 37. Minus a negative becomes plus. 12 plus 37 gives you 49. The square root of 49 is equal to 7. 7 plus 7 does equal 14. So since the left side equals the right side, this confirms that x does equal negative 37. Question number 3, we were given the square root of x plus 23 minus the square root of x minus 7 is equal to 5. To isolate the first radical, step 1, add the second radical to both sides. These cancel each other out, leaving you with just the square root of x plus 23 on the left side. And on the right side, we have 5 plus the square root of x minus 7. So now that we've successfully isolated this first radical, to remove it, we raise both sides to a power of 2. And that leaves you with x plus 23 on the left side is equal to 5 plus the square root of x minus 7 squared on the right side. So now we will need to use the FOIL method to expand this expression. 5 times 5 gives you 25. 5 times the square root of x minus 7 is equal to 5 radical x minus 7. When we do that again, 5 times radical x minus 7, we add this 5 to the previous 5, giving us 10 radical x minus 7. And then you multiply the last terms, radical x minus 7 times itself, radical x minus 7, leaves you with just the radicand, x minus 7. 25 minus 7 would be 18. So we want to move that 18 to this side and this x to this side so that leaves you with just the second radical on the right side. So step 4, subtract x from both sides. X minus x is 0x. And then step 5, the 25 minus 7 again gives us 18. So step 5 is subtract 18 from both sides. 23 minus 18 gives you 5. So once we remove the first radical and move the other terms to the left side, we are left with 5 is equal to 10 radical x minus 7. And now step 6, raise both sides to a power of 2 to get rid of this radical. When we do so, 5 squared equals 25. And on the right side, 10 squared equals 100. The radical times itself gives us x minus 7. We have to distribute this 100 to the x. So we get 100x. N to the negative 7. So you get negative 700. And now we can solve for x. Step 7. So we have 25 is equal to 100x minus 700. X appears once, so we can solve for x. First, remove the constant. So we add 700 to both sides. 25 plus 700 is 725. To get rid of the coefficient 100, we divide both sides by 100. 725 divided by 100 is 7.25. So the answer to question number 3 is x is equal to 7.25. Then lastly, step 8, check the answer by plugging it into the original equation. The square root of x plus 23 minus the square root of x minus 7 is equal to 5. When you plug in 7.25 in both places where you see x, you wind up with 7.25 plus 23, which gives you radical 30.25. The square root of 30.25 is 5.5. And our second radical term, 7.25 minus 7, is the square root of 0.25. And the square root of 0.25 is 0.5. So we wind up with 5.5 minus 1/2, which is equal to 5. Confirming that the left side of the equation equals the right side, which means x is equal to 7.25. So that is how you would go about removing the radical signs from an equation and then solving for x algebraically. But if x appears more than once after the radical signs are removed, then we'll need to solve by either factoring the resulting polynomial or by utilizing the quadratic formula, which we'll get to next. But let's first discuss factoring. Once the radical signs are removed, if a polynomial remains, then try factoring it to solve for the variable. So let's say you started with the radical equation, radical x plus 10 is equal to x plus 4. You would remove the radical and then move these terms to one side of the equation, leaving you with 0 on one side, and the polynomial x squared plus 7x plus 6. And then once you factor this, you would wind up with 0 is equal to x plus 6 times x plus 1. So this is the basic flow that we're aiming for. So let's dive deeper into the details about each of these steps. If the coefficient of x squared is 1, then the polynomial can be factored if the coefficient of x is equal to the sum of the factors of c. So let's break this statement down a bit. First, we want the coefficient of x squared to be 1. If the coefficient is not 1, that doesn't necessarily mean that it can't be factored, but it makes it a lot harder to factor the polynomial. So for us, when we're going to try factoring, we want the coefficient of x squared to be 1. So that's the first good thing. And then once we see the coefficient of x squared is 1, you then want to look at the second and third term of the polynomial. And again, the polynomial can be factored if at this point the coefficient of x is equal to the sum of two of the factors of c. So when you have your resulting polynomial, you want to look at the constant and consider the factors. So what are the factors of 6? Well, 1 times 6 would give us 6. So you look at the sum of those factors. 1 plus 6 is equal to 7, which is the coefficient of x. So these are the factors that we're looking for as far as the factors of 6. If you consider the other factors, so in this case, 2 times 3 would also get us a 6. But the sum of these factors, 2 plus 3, does not equal the coefficient of x. So that is how you know it is these factors that we're looking for. Now, once you've determined which factors of c have a sum of b, we want to create the factors for the polynomial. So once the factors of c are determined, then create the factors of the polynomial by adding the variable x to each of these factors inside a pair of parentheses. So x plus 1 is one factor, and you're multiplying that times x plus the other factor, which would be 6. So this polynomial, x squared plus 7x plus 6, is equal to x plus 1 times x plus 6. Each of the factors added to x inside a pair of parentheses, and you multiply those. Once you have the factors of the polynomial, you want to set each one equal to 0 and solve for x, and this is because of the zero product rule. If a product equals 0, then one or both of the factors must be equal to 0. So as a result of this, you want to set each factor equal to 0 and solve for the variable x. So we had 0 is equal to x plus 1 times x plus 6. And the only way that two numbers equal 0 is if one of them equals 0. So either this one is 0 or this factor is 0. So you solve both for x, and then we're going to check both values. So x plus 1 is equal to 0 will give you x is equal to -1 as one value of x. And x plus 6 is equal to 0 would leave you with x is equal to -6 as the second potential value for x. So that is how you would go about solving the polynomial by factoring it. Let's take a look at a practice question from start to finish. So you would be given the question, solve for x and check the answers. Radical x plus 6 minus x is equal to 0. So how would we go about solving this? The first thing we do is we want to isolate our radical sign. So we add x to both sides. That leaves you with the square root of x plus 6 on the left side and 0 plus x, which is x on the right side. Since the index here is 2, step 2 is you want to raise both sides of the equation to a power of 2, leaving you with x plus 6 on the left side and x squared on the right side. Since x appears more than once, we want to move these terms to the same side. So we subtract x and subtract 6 from both sides. So step 3, subtract x from both sides. And step 4, subtract 6 from both sides. X minus x is 0. 6 minus 6 is 0, leaving you with 0 on the left side. And now on the right side, we have x squared minus x minus 6. So we have our polynomial, and we have 0 on one side, which we need. If you had a constant, you want to move that over as well. So we have 0 is equal to x squared minus x minus 6. So we have a polynomial, and the coefficient of x squared is 1. So we want to consider the factors of c to see if they can equal the sum of b. The factors of -6, that would give you -1, are -3 and +2. -3 times +2 is -6. -3 plus 2 is -1. So 0 is equal to x squared minus x minus 6 is equal to x minus 3 times x plus 2. So we have factored the polynomial successfully. And now step 6, you want to set each factor equal to 0. So x minus 3 is equal to 0, and x plus 2 is equal to 0. And now we solve for x. So x minus 3 is equal to 0, so we add 3 to both sides, leaving us with x is equal to 3 as one potential answer. And then our second factor, x plus 2 is equal to 0. You subtract 2 from both sides, leaving you with x is equal to -2 as our second potential answer. And now lastly, step 8, check the answers by plugging each number into the original inequality. So that was the square root of x plus 6 minus x is equal to 0. We first want to check -2 by plugging it in both places where you see x. So that gives you -2 plus 6, which is 4. The square root of 4 is 2. 2 minus -2 gives you 2 plus 2, which equals 4. And 4 is not equal to 0. So since the left side does not equal the right side, this is not a valid answer. So x does not equal -2. Let's test the second answer that we got, +3. 3 plus 6 is 9. The square root of 9 is 3. And 3 minus 3 gives you 0. Confirming the left side of the equation equals the right side of the equation when x is equal to 3. So the only correct value for x in this question is +3. So that is an example of a radical equation that you would solve utilizing factoring to solve for x. Let's now have you do a few practice questions. Solve for x and check the answers. Question number 1, the square root of x minus 4 plus x is equal to 4. Question number 2, the square root of 5x plus 6 minus x is equal to 2. And question number 3, the square root of 3x plus 4 minus the square root of 2x plus 1 is equal to 1. Pause the video answer these questions and then press play when you are ready to begin. Question number 1. The square root of x minus 4 plus x is equal to 4. So you want to isolate the first radical. You do that by step 1, subtract x from both sides. That leaves you with the square root of x minus 4 on the left side of your equation and 4 minus x on the right side. You now, step 2, want to raise both sides of the equation to a power of 2. That negates this radical sign, leaving you with x minus 4 on the left side and 4 minus x squared on the right side. And step 3 will be to use the FOIL method to expand this expression, 4 minus x squared. When we do so, 4 times 4 is 16. 4 times negative x is negative 4x. Negative x times 4 is negative 4x. Negative 4x minus 4x is negative 8x. And negative x times negative x gives you plus x squared. So now we've removed our radical sign. We want to move these terms to the same side of the equation, so we get 0 on one side. So step 4, subtract x from both sides. Negative 8x minus x is negative 9x. We have positive x squared. And then step 5, add 4 to both sides. So we have 0 on the left side. 16 plus 4 is 20 on the right side. So now we have the polynomial 0 is equal to x squared minus 9x plus 20. Our coefficient of x squared is 1. So we want to consider the factors of 20 and see if any of them have a sum of negative 9. And those factors would be negative 5 and negative 4. So step 6, when we factor the polynomial, we get x minus 5 times x minus 4. Negative 5 times negative 4 is positive 20. Negative 5 minus 4 is negative 9. So this can be factored to 0 is equal to x minus 5 times x minus 4. And we set each factor equal to 0. So x minus 5 is equal to 0, and x minus 4 is equal to 0. And now we want to solve each of these for x. X minus 5 is equal to 0. To solve for x, we add 5 to both sides, leaving us with x is equal to 5 as one potential answer. The second factor we had was x minus 4. So to solve x minus 4 is equal to 0, we add 4 to both sides, leaving us with x is equal to 4 as our second potential answer. And now step 9, we check the answers by plugging each number into the original equation. The square root of x minus 4 plus x is equal to 4. So we first plug in our first potential answer, 4, in each place where we see x. 4 minus 4 is 0. The square root of 0 is 0. So we're left with 4 is equal to 4, which confirms that x does equal 4. And now we test 5. The square root of 5 minus 4 is equal to the square root of 1, which is equal to 1. Plus x is plus 5. So 1 plus 5 is equal to 6. And since 6 does not equal 4, x does not equal 5. So the only answer to question number 1 is x is equal to 4. Question number 2, we had the square root of 5x plus 6 minus x is equal to 2. Step 1, add x to both sides, isolating the first radical, the square root of 5x plus 6. And on the right side, we have 2 plus x, which is the same as x plus 2. To remove this radical sign, we are going to raise both sides to a power of 2, leaving you with 5x plus 6 on the left side of the equation, and x plus 2 squared on the right side of the equation. Then step 3, expand this expression by using the FOIL method. So x plus 2 times x plus 2 gives us x times x, which is x squared, x times 2, which is 2x, 2 times x, which is 2x, 2x and 2x combine to give you 4x, and 2 times 2, which is positive 4. So now we want to get 0 on one side of the equation. So step 4, subtract 5x from both sides. And step 5, subtract 6 from both sides. 5x minus 5x is 0. 6 minus 6 is 0. So that is how we get our desired 0 on one side. And now on the right side, 4x minus 5x is negative x. 4 minus 6 is negative 2. So we are left with the polynomial 0 is equal to x squared minus x minus 2. Now we see the coefficient of x squared is 1. So we consider factoring by thinking about the factors of negative 2. Are there factors of negative 2 that have a sum of negative 1? That would be negative 2 and positive 1. So step 6, factor the polynomial. And when you do, we get x minus 2 times x plus 1. Negative 2 times positive 1 have a product of negative 2. Negative 2 plus 1 have a sum of negative 1. So these are our factors. And now step 7, set each factor equal to 0. So x minus 2 is equal to 0 and x plus 1 is equal to 0. And now we want to solve each of these for x. So x minus 2 is equal to 0. We add 2 to both sides, giving us our first potential answer of x is equal to 2. The second factor was x plus 1. We subtract 1 from both sides, giving us our second potential answer of x is equal to negative 1. So now we want to check the answers by plugging each number into the original equation. The square root of 5x plus 6 minus x is equal to 2. So let's first plug in negative 1 in both places where we see x. 5 times negative 1 is negative 5. Negative 5 plus 6 is positive 1. We have minus negative 1, so minus a negative gives you plus. The square root of 1 is 1. 1 plus 1 is 2. And since the left side, 2, equals the right side, which is 2, that confirms that x does equal negative 1. And now the second value for x, 2. When we plug in 2 for x, we have 5 times 2, which is 10. 10 plus 6 is 16. Minus x, so minus 2. The square root of 16 is 4. 4 minus 2 is 2. Since 2 is equal to 2, that confirms that the value for x, which was 2, is correct as well. So for question number 2, both negative 1 and positive 2 are valid values for x. And now let's take a look at question number 3. The square root of 3x plus 4 minus the square root of 2x plus 1 is equal to 1. So we want to isolate the first radical. So step 1, add the second radical to both sides, leaving you with the square root of 3x plus 4 on one side, and 1 plus the square root of 2x plus 1 on the right side. To get rid of this radical sign, we want to raise both sides of the equation to a power of 2, leaving us with 3x plus 4 on the left side, and 1 plus the square root of 2x plus 1 squared on the right side. And now step 3, use the FOIL method to expand this expression on the right. So 1 plus the square root of 2x plus 1 times itself, squared. So our first terms, 1 times 1 equals 1. our outside terms, 1 times the square root of 2x plus 1 is the square root of 2x plus 1. When we do that again, 1 times the square root of 2x plus 1, we're going to add that to this one. So that gives us the square root of 2x plus 1 plus the square root of 2x plus 1. We combine those together to get 2 times the square root of 2x plus 1. And then our last term of each binomial, when we multiply the square root of 2x plus 1 times itself, we are left with 2x plus 1. So now our first radical sign is completely removed. So we want to isolate our second radical sign. 1 plus 1 is 2. So we want to subtract that 2. And then we have 2x on this side of the radical. So we want to subtract 2x from both sides as well. When we subtract 2 and 2x from both sides, we are left with 3x minus 2x, which is x. 4 minus 2, which is 2. And now we are left with just our second radical on the right side, 2 radical 2x plus 1. So step 6, raise both sides to a power of 2 so that we can remove this radical. When we do, we have x plus 2 squared. And on the right side, we have 2 radical 2x plus 1 squared. 2 squared is 4. And then any radical times itself is just the radicand. So the square root of 2x plus 1 times the square root of 2x plus 1 gives us 2x plus 1. 4 times 2x is 8x. 4 times 1 is 4. So we have x plus 2 squared is equal to 8x plus 4. And now we want to use the FOIL method to expand this expression. So we have 8x plus 4 is equal to, so we multiply the first terms, x times x is x squared. Our outside terms, x times 2 is 2x. Our inside terms, 2 times x is 2x. 2x plus 2x is 4x. And then our last terms, 2 times 2 is 4. So for steps 8 and 9, you want to subtract 8x from both sides and subtract 4 from both sides so that we can be left with 0 on one side of our equation. And now on the right side, we have x squared. 4x minus 8x is negative 4x. And 4 minus 4 is 0, so those cancel out. So we are left with the polynomial 0 is equal to x squared minus 4x. When you don't have a constant c, and you have two terms that both have x, that x can be removed from each term. So when you remove one x from these two x's, you have just x. When you remove x from negative 4x, you have just negative 4. And you put the x on the outside. So this is reverse distribution. To confirm, you just go the opposite way to make sure you got your previous terms. X times x is x squared. X times negative 4 is negative 4x. So once you factor the polynomial, you want to set each of these factors equal to 0. So x is equal to 0 is one possible value for x. And our second factor, x minus 4, we set that equal to 0 and solve for x. Add 4 to both sides. So our second potential value is x is equal to 4. And now step 13, check the answers. X is 0 and x is equal to 4 by plugging each number into the original equation. The original equation was the square root of 3x plus 4 minus the square root of 2x plus 1 is equal to 1. We check 0 by plugging 0 in for x. 3 times 0 is 0, so we have the square root of 4. 2 times 0 is 0, so the second term is the square root of 1. The square root of 4 is 2. The square root of 1 is 1. So we have the first term minus the second term, which is 2 minus 1, which is equal to 1. So once we see 1 is equal to 1, and the left side equals the right side, that confirms that x is equal to 0 is a valid value for x. And then we check the second value, 4, by plugging it in for x. 3 times 4 is 12. 12 plus 4 is 16. 2 times 4 is 8. 8 plus 1 is 9. The square root of 16 is 4. The square root of 9 is 3. Leaving you with 4 minus 3, which is equal to 1. And again, since the left side equals the right side, that confirms that x does equal 4 as well. So that is how you would go about solving radical equations that would require factoring the polynomial to solve for the variable x. Let's now wrap things up by taking a look at solving these equations by using the quadratic formula to solve for x at the end of the process. So this is after the radicals have been removed already. So once the radical signs are removed, if the resulting polynomial is quadratic but not factorable, then use the quadratic formula to solve for the variable. So let's say we had 0 is equal to x squared minus 8x plus 1. Our coefficient of x squared is 1. So we're thinking, okay, maybe we can factor. But then our c is 1. So the only factors of 1 are 1 times 1, which makes finding factors that have a sum of -8 impossible. So although the coefficient of x squared here is 1, this term cannot be factored, so you would use the quadratic formula to solve for x. This is another example of a polynomial that you would use the quadratic formula with to solve for x. So we have 0 on one side, as always. 0 is equal to 2x squared plus 3x minus 7. We can't remove the 2 from each term, so we're left with this expression, 2x squared plus 3x minus 7. So you would plug 2, 3, and -7 into the quadratic formula, which is this. You want to memorize this. X is equal to -b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Write this down and just have it beside you handy so that you can use it at the end of each of these questions coming up. And we're going to plug in a, b, and c into this formula to solve for the variable x. So back to the polynomial we had a second ago. 0 is equal to x squared minus 8x plus 1. A is the coefficient of x squared. When there's nothing there, it's 1. 1 times x squared is x squared. So when it's not shown, the coefficient is 1. B is the coefficient of x, so it's -8. And c is +1. So we plug each of these into their respective places in the quadratic formula. So 1 goes here and here. -8 goes here and here. And c goes here, leaving us with x is equal to -b, which is negative times -8, plus or minus the square root of b squared, so that's -8 squared, minus 4 times a, which is 1, times c, which is 1, over 2 times a, which is 1. So for step 1, you plug a, b, and c into the quadratic formula, and then step 2, you solve for x. So you evaluate this expression. So here we have -1 times -8, which is +8, over 2 times 1, which is 2, plus or minus b squared, which is -8 squared, which is 64, minus 4 times 1 times 1, which is 4. 64 minus 4 is 60. We can simplify this further. Radical 60 is equal to radical 4 times radical 15. And we want to separate radical 60 into these factors because the square root of 4 is equal to 2. So we can negate the 2 in the numerator with the 2 in the denominator. So that leaves us with 8 over 2, which is 4. 4 plus or minus the square root of 15. So we were able to solve for x by plugging the coefficient of x squared, the coefficient of x, and our constant c into the quadratic formula. And then we solve for two values of x, 4 plus the square root of 15 and 4 minus the square root of 15. And then we would check this answer by plugging it into the original equation like we did for the other methods. That is how you utilize the quadratic formula in relation to radical equations. You remove the radical signs, you create the polynomial, and if the polynomial cannot be factored, you plug the respective values into the quadratic formula to solve for x. And then you can check the answers the way you normally would by plugging them into the original equation. So let's wrap this video up by having you complete 2 practice questions. Solve for x and check the answers. Question number 1, the square root of 6x plus 4 minus 2x is equal to 0. Question number 2, the square root of 10 minus x squared minus 2 is equal to x. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. The square root of 6x plus 4 minus 2x is equal to 0. So we always want to isolate the first radical. So step 1, add 2x to both sides, leaving you with just the radical, the square root of 6x plus 4 on the left side, and 0 plus 2x leaves you with just 2x on the right side. Now we want to remove this radical sign, so we want to raise both sides of the equation to a power of 2, leaving you with just 6x plus 4 on the left side, and 2x squared on the right side, which would give you 4x squared. Now that the radical sign is removed, we want all of these terms on one side of the equation. So step 3, subtract 6x from both sides, and step 4, subtract 4 from both sides. This way we get 0 on one side, which we always want, is equal to 4x squared minus 6x minus 4. So now we have our polynomial. 0 is equal to 4x squared minus 6x minus 4. So we want to plug a, b, and c into the quadratic formula. So that's step 5. So a is the coefficient of x squared, so that's 4. B is the coefficient of x, so that would be negative 6. And c is the constant without the variable, which would be negative 4. So we plug a, b, and c into the quadratic formula, and that would give us x is equal to negative 1 times negative 6 plus or minus the square root of negative 6 squared minus 4 times negative 4 over 2 times 4. So now we want to solve for x by evaluating this expression. Negative 1 times negative 6 is positive 6, plus or minus negative 6 squared is 36, 4 times 4 is 16, negative 16 times negative 4 is positive 64. So then 36 plus 64 is equal to 100. We break this up into 2 fractions, 6 over 8, plus or minus the square root of 100 over 8. We can evaluate this further. The square root of 100 is equal to 10. So we see x is equal to 6/8 minus 10 over 8. So that would be negative 4 over 8. And x also equals 6/8 plus 10 over 8. And that would equal 16 over 8. So negative 4 over 8 is negative 1/2. And 16 over 8 is positive 2. So we see x is equal to negative 1/2 and positive 2. So now that we've solved for x, step 7, check the answers by plugging each number into the original equation. The original equation was the square root of 6x plus 4 minus 2x is equal to 0. When we plug in negative 1/2 for x, we get 6 times negative 1/2, which would be negative 3. Negative 3 plus 4 is positive 1. Negative 2 times negative 1/2 is positive 1. So that's how we get this. The square root of 1 is 1. So when we plug in x is equal to negative 1/2, we get 1 plus 1, which is 2. And that does not equal 0. So x does not equal negative 1/2. This is not a valid answer. So we want to check the other answer we got, which was positive 2. 6 times 2 is 12. 12 plus 4 is 16. Negative 2 times 2 is negative 4. The square root of 16 is 4. So we wind up with 4 minus 4, which is 0. And since 0 is equal to 0, left is equal to the right, that shows that x does equal 2. So the answer to question number 1 is x is equal to 2. Now let's have a look at the second practice question. The square root of 10 minus x squared minus 2 is equal to x. Step 1, add 2 to both sides, leaving you with the square root of 10 minus x squared is equal to x plus 2. Step 2, raise both sides to a power of 2, leaving you with 10 minus x squared on the left side and x plus 2 squared on the right side. So step 3, we are going to use the FOIL method to expand this expression, x plus 2 squared. So x plus 2 times x plus 2. X times x gives us x squared. X times 2 gives us 2x. 2 times x is 2x. 2x plus 2x is 4x. And then 2 times 2 is positive 4. So once we remove the radical and expand our expression, we are left with 10 minus x squared is equal to x squared plus 4x plus 4. We want to have 0 on one side, so we're going to subtract 10 and add x squared to both sides. So those are step 4 and step 5. Add x squared to both sides and subtract 10 from both sides, leaving us with 0 on the left side is equal to x squared plus x squared, which is 2x squared, plus 4x, and then 4 minus 10 is negative 6. So the polynomial we have is 0 is equal to 2x squared plus 4x minus 6. Now this 2 can be extracted from each term, but let's say that you don't recognize that. So we're going to continue with the original plan of using the quadratic formula. So step 6, plug A, which is 2, B, which is positive 4, and C, which is negative 6, into the quadratic formula. And then step 7, solve for x. So negative B is negative 1 times 4, plus or minus the square root of B squared, which is 4 squared, minus 4ac, which is 4 times 2 times negative 6, over 2a, which is 2 times 2. So that is how we wind up with this. Negative b squared minus 4 times a times c over 2 times a. And then we can solve for x by evaluating this further. Negative 1 times 4 is negative 4. 2 times 2 is 4. Plus or minus the square root of 4 squared, which is 16. Negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48. 16 plus 48 is 64. So we wind up with negative 4 over 4. Plus or minus the square root of 64 over 4. The denominator goes here and here. We can evaluate this term further. The square root of 64 is 8. So we see x is equal to negative 4 over 4 minus 8 over 4. Negative 4 minus 8 would be negative 12 over 4. And then negative 4 over 4 plus 8 gives you positive 4. Negative 4 plus 8, positive 4. So x is equal to negative 12 over 4, which is negative 3, and 4 over 4, which is positive 1. So we get x is equal to negative 3 and positive 1. And then step 8, check the answers by plugging each number into the original equation. The square root of 10 minus x squared minus 2 is equal to x. Plug in negative 3 in both places where you see x. 10 minus negative 3 squared is 10 minus 9. Negative 3 squared is positive 9. 10 minus 9 is positive 1. The square root of 1 is 1. 1 minus 2 is negative 1. And since negative 1 does not equal negative 3, then that means that x does not equal negative 3. This is not a valid answer. Now let's check positive 1. 10 minus 1 squared is 10 minus 1, which is 9. The square root of 9 is 3. 3 minus 2 is positive 1. So we get 1 is equal to 1, which proves x does equal positive 1. So the answer to question number 2 is x is equal to 1. And that wraps up this chapter on solving radical equations. Feel free to leave your follow-up questions in the comments section, or of course contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.